Okay, this is Coach Williams, and I am going to redo this video for you guys that we've seen in class. We actually did this in class already on Tuesday. This is going to be a review for your Chapter 4 test, which will be on Thursday. I'm going to move a little quicker than I did in class because this should be, again, like I said, a redo of what you've already seen. But I want to make this video available for you so that you could see it online at home in the evenings. The very beginning of the chapter 4.1.4.2 talks about writing an equation in slope-intercept form. With given characteristics, we'll say they're going to give us a slope, they're going to give us y-intercept, or they're going to give us a point. In this case, they give us a point that actually helps us find the y-intercept pretty quick. We'll recognize that in just a second. To begin with, they want slope-intercept form, so they want y equals mx plus b format. That is your slope-intercept form. So if they want that, and they give us the slope, this is the m, right? And this is my b. So this helps us go ahead and just plop these numbers right into the form, slope-intercept form. So y is just going to simply equal the slope times x plus b. The next thing we're going to have to do is on number 2, we're going to have to look at and determine that they've actually given us the y-intercept by giving us this point 0, 0. When we have an x value of 0, the y value in that point is going to be our y-intercept. So whenever you're looking at this right here, you've got a point at 0, 0. This value right here is our y-intercept. This is our b, so b is going to equal 0. Anyway, so we're going to go on here. We can write, we have our slope, we have our 0. We can write our equation as y equals negative 4x plus 0. And if you wanted to simplify that, you could actually just leave this as negative 4x. So y equals 4x. So that is the first two. And you're going to notice that this is going to happen quite often throughout this paper. They're going to give you the y-intercept in the form of a point. And hopefully we'll start to recognize and see that as we move along. All right, so moving on to the next part. These are two graphs that they've given us. And on these two graphs, like I said, I'm going to move kind of fast because you have the ability to pause this if you need to write down these notes. But on these two graphs, you're going to notice in the situation where you have a graph, you're going to see your y-intercept on the graph when the line crosses the y-axis here. But again, they do give us the point value, and once again, we have an x value that is a 0. And so we know that this is our y-intercept, or the b value. So the b value in this case is going to be a 3. Now, we can also find the slope by using 2 points, using our 2-point slope formula, which is y2 minus y1 all over x2 minus x1. But having the graph, we can also just count from the left point to the right point, going down, up and down first, our change in y over the change in x. And so the change in y here is down 1. So our slope is actually going to be down 1, which means negative. And then we're going to go to the right 2 spaces. And so it's going to be a negative 1 over 2. We'll rewrite that as negative 1 over 2. So now we have our y-intercept, and we have our slope. So we can just drop that into our formula. Y is going to equal negative 1/2 x plus 3. And that is it. Now, if you didn't recognize that this was the y-intercept, you could actually put this slope that we found here, and or if you found it this way, using the y2 minus y1 over x2 minus x1, you could put the slope together with one of these points in the point slope form, and then you could rearrange it to be in this slope-intercept form. And so if you were wanting to do that, of course the formula for that would just be, I'll write it here above it, y minus y1 equals m times x minus x1. And we may actually do an example of that here on one of the next few problems. I'm going to show you that most of the problems in here are going to give us the y-intercept in the form of the point, but we may work one using this form and transferring it into or rearranging it into the slope-intercept form. But this is the point-slope form because they give you a point and they give you a slope, and we'll see more of that as we move along. In number 4, they again give us the y-intercept here. We know it crosses the y-axis at +1, and so we know that our b is going to be 1. And then our slope, moving up and down first, going from the left point to the right point, our slope is going to be 1, 2, 3, 4 in the positive direction, up, and then it's going to go across 3 or over 3. And so it is the change in y over the change in x. So this will be 4/3. And so we can put that into our equation, y equals 4/3 x plus 1. And that is it. We are done with writing the equation in slope-intercept form of these two. Let's move on to number 5 and 6. On number 5 and 6, they give us 2 points. Hopefully by now we've mentioned it several times. You can recognize that this point here, having the x value as a 0, is my y-intercept. So this is my y-intercept. So my b value is going to be a 9. This makes it easy. We don't have to write it in a different form and try to convert it to our slope-intercept form. But we do have to find our slope here. We don't have a graph to count from one point to the other. So we're going to have to use our m is equal to y2 minus y1 all over x2 minus x1. With that being said, this we'll use as our point 2. This we'll use as point 1. And so we'll take our y's and subtract those. And then we'll have our x's and we'll subtract those, subtracting y's on top of x's. So this will lead us to 9 minus 3 all over 0 minus 2, which then gives us a 6 over negative 2. And when we simplify that, dividing this by 2, we'll get 3, and the negative makes this a negative 3. So we have our slope. We have our y-intercept, we have our slope. Now we can write our equation in slope-intercept form. Y equals negative 3x plus 9. And that's the answer to number 5. On number 6, again, they've made it easy for us. They've given us this point here, which is going to be our y-intercept. So the b value is going to be a negative 2. That's going to be making it easy for us. We don't have to actually, put this in a different form and change it to slope-intercept form. We will have to find our slope using 2 points. So we're going to have to take a negative 2, subtract 4 by taking this with our y's. Now we're going to do our x's on the bottom, 0 minus a negative 1. Notice this is minus a negative 1. Put that in parentheses, kind of helps us separate that. This is going to be negative 2 and negative 4. When we combine those, we're going to have a negative 6. All over negative, negative, which means positive, so that's just going to be all over a positive 1. And when we simplify this, it's actually just negative 6. So now we have our slope, we have our y-intercept. We can write our equation. Y is going to equal negative 6x minus 2. And that is the equation in slope-intercept form of the line that passes through the given points on number 6. Let's turn the page. On to the back, we have, actually this is on 7 and 8, this is going to be a different representation of points. They give it to us in a function form, we'll say, but this is not very hard at all. In fact, you're going to see that this is going to look just like 5 and 6 once we get to one step here. The first step, you'll notice that this is going to be just like our previous two problems where we have 2 points. What they're saying here whenever they give us f at 0 is equal to 3, remember that we could rewrite this as f of x is equal to y. And if you just match up the positions here of these variables, you could see real quick that when we plug in a 0 for x, the y value that comes out is a 3. And this is just an ordered pair. An ordered pair is a solution to an equation, in this case a function. And so we have a point at 0, 3. When we put in a 0 in the function, we get a 3 whenever for the output value. And then our next point, if you follow that same format, this is f of x equals y. So my x value is a 1. My y value is going to be a 5. And like we mentioned, this is now looking just like the previous two problems. We have 2 points. We have to write a linear function or the equation of a linear function with these given values. So you'll also notice again, hopefully you're recognizing this, they've given us the y-intercept. This is a 0 for x, and so the y-intercept is going to be 3. So we know from this, I'll write it on this side, b is equal to 3. So that's going to be helpful in just a minute. And we've got 2 points. We're going to have to use the 2-point slope form to find out what the slope is. 5 minus 3 all over 1 minus 0. And that's going to give us 2 over 1. And so 2 over 1 obviously is just 2. So that is our slope. Now we have our y-intercept and our slope. We can write this in slope-intercept form. Y equals 2x plus 3. On to number 8. Again, we'll try to move a little faster here. We already know that this is just going to be 3 and negative 2. X is 3, y is negative 2. And x in this case will be 0, and y will be a 1. So we have our 2 points. They've also given this our y-intercept again. And so b is going to be equal to positive 1. Finding our slope, m is equal to 1 minus a negative 2, all over 0 minus 3. When we take 1 minus a negative, that would be 1 plus 2. So that gives us 3 over a negative 3. And so our slope is going to be a negative 1. 3 divided by 3 is 1. We have a negative, so it makes it negative 1. So this one will be y equals a negative x, or negative 1x, it's the same thing, plus 1. So you could leave it just like this. If you wanted to put a negative 1 in front of that x, it's just kind of understood that it's there, but if you wanted to put a negative 1 in front of that x, that would also be an acceptable answer. Okay, moving on to the number 9, the word problem here. The word problem is giving you an example of a t-shirt company that charges an initial fee. Circle that initial fee of $25. This is something I like to teach here whenever we're using this. Initial fees in most cases are going to be your y-intercept. This will be, draw a little arrow out or coming into it, this will be our y-intercept, or the b term in our equation. All right, the initial fee, because at 0, if you are going to order t-shirts from this company, the first thing you're going to have to do is pay $25 to create the team's design. Before you enter, however many shirts you're going to order. Now that's the next thing. They're going to charge you $8 per shirt. And so if you think about it, it's all depending on how many shirts you order. Your cost is going to be dependent on how many shirts you ordered plus this B term. So 8 is going to be your slope. It's going to be your M. If you think about it, it's something, or mx plus b. In this case, it's going to be 8 times every shirt plus the initial cost of $25. So if we're writing a linear model to represent the total cost of your team's t-shirts with your design as a function of the number of t-shirts, then we can do it like this. We could say f of x, and we're going to do that where x is equal to the number of shirts. Okay, so that's what we're writing this function where x is the number of shirts. F of x is going to be equal to 8x plus $25. If you wanted to say it in a different way, and we can always just replace f of x with a different letter, we'll call this the total cost. Cost is going to be equal to 8x plus 25. And that is a linear model that represents the total cost based on how many shirts you order times 8 and then plus the initial fee of $25. Now part B is actually asking us to find a value, a total cost, when we have 35 members that are going to purchase a shirt here. So all we're going to do here, in a specific way of writing this, we're going to put our function at a value of 35. So f at 35 t-shirts. That's going to be equal to 8 times 35 t-shirts plus the $25 initial cost. Or again, you could just say the total cost is going to be 8 times 35 people or members plus the $25 initial fee. When we multiply that out, C is going to be equal to $280 plus the $25. Don't forget the 25. So the total cost is going to be $305. And that is your answer for 9B. All right, the last 4 problems are going to be dealing with point slope form. And they really want you to recognize that number 10 and number 11 they're already in point slope form. And if you know what the point slope form is, then you should be able to pull out certain values. In this case, they want you to identify a point, and they want you to identify the slope. If you know what the point slope form is, it's just simply y minus y1, we mentioned it earlier, is equal to m times x minus x1. And so, looking at this, we should be able to pull out our slope, our m value, and we can pull out the y1 and the x1 value to create the point that they're looking for that is on the line or that the line passes through. So in this first one, we have m right there. We have our y1 and our x1 values right there. So the slope is going to be a positive 1/4. And the point that we're going to need here is matching the form. That's going to be important here. We'll see that on number 11 here in a minute. Y minus matches the form. So all we do is pull the value after the minus sign and the value here after the minus sign. So the x1 value is 5 and the y1 value is 2. So there's our point 5,2 with a slope of 1/4. On number 11, we're going to have to do a little bit of work here because this is not in the form of x minus, it's in the form x plus. Well, if we're going to change this to x minus, I'm going to rewrite this. Y minus 7 is going to be equal to negative 3 times x minus. And the only way I can get to a plus from this minus is to have another minus. So I'm going to have to put another one in front of 6. And then that now looks like the form that we have up here, x minus. So x minus, and then I can take whatever's after the minus and create my point from that, and then also take my slope from right in front of the parentheses here. So m is going to be equal to a negative 3, and my point is going to be negative 6, comma 7. And that will be the point and the slope for number 11. Now looking at 12 and 13, write an equation in point-slope form of the line that passes through the given point and has the given slope. Again, this is not very difficult at all. If we know the formula, which is, or the point-slope form, which is right here, then we can write this pretty quickly into that form. Y minus the y value, which is a 5, is going to be equal to the slope 1 times x minus a negative 4. All right, so we're going to have y minus 5 equal 1 times x minus a negative 4. Now, the two minuses will just make a plus, so this will be y minus 5 equal to 1 times x plus 4. And that's it. We don't need to change, simplify, rearrange. They'd want it in point-slope form. That's what they get right here. Okay, number 13, we're going to do the same thing. We're going to have y minus a negative 6. So we got to put that in parentheses. It's going to be equal to, and this is a little negative in front of that. It's kind of hard to see on the print, but this is a negative 1/4 times x minus 2. The only thing we're going to need to simplify here is just this negative negative, which makes it a plus. So y plus 6 is going to be equal to negative 1/4 x minus 2 in parentheses, and that is point-slope form. Nothing else needs to be done to it. Okay, that wraps up our homework check for 4.1, 4.2. Hopefully this has been another help to you in just reiterating all the things that we should have covered in class, or if you happen to miss class, hopefully this will help you get a good review before our tests. We'll follow this up with the next homework checks. Hope you enjoy the video.